Now in this last video for the chapter, we're going to look at some environmental issues such as the depletion of the ozone layer and global warming. Now the depletion of the ozone layer, I suppose this is not entirely new. You would have encountered this in either your geography or your lower secondary science or even your primary school science. Is that Earth has a layer of ozone in the atmosphere. So this is planet Earth. I hope I'm drawing it well enough. So it has a layer of ozone in the atmosphere, and what this layer of ozone is that it prevents harmful UV rays from reaching the surface of the Earth. But the use of ozone depleting chemicals, notably your CFCs, in the early 70s, 80s, I guess, resulted in the thinning and the depletion of your ozone layer. Why? Because the release of your CFCs into the atmosphere can actually cause a reaction with your ozone. Now the important thing to take note for this part is two things. What are chlorofluorocarbons? Chlorofluorocarbons are compounds that contains carbon, chlorine and fluorine. Okay, so for example, this is a chlorofluorocarbon. Alright, so it is a compound that contains carbon, chlorine and fluorine. Now the important thing to remember here is that the chlorine atoms are essentially responsible for reacting with ozone. Okay, so this is the commonly tested concept. In a CFC, the part that is responsible for reacting with ozone is your chlorine atoms, because when you release CFCs into the environment, in the atmosphere, radiation can actually cause the CCl bond to break, which leads to the formation of chlorine atoms. And chlorine atoms, if you look at the electronic configuration, it is not stable. In fact, it has an unpaired electron. In later on you will learn that it's called a radical. So it's highly reactive. It's going to react with ozone to form something else, leading to the removal or the depletion of ozone. Now we'll look at the phenomenon of global warming. And for that, if you were to find a graph of the amount of CO2 in air through the years, alright, from long way back in time until today, you'll see something like this, right? Before the 1900s, the amount of CO2 in air is fairly constant, and then after that there is a steady increase and it goes all the way up, and it's continuing to climb. Now the question is, why would the amount of CO2 in air be constant before the 1900s? Okay, is carbon dioxide not produced back then? And why is it not increasing? Why is the amount of CO2 not increasing? Okay, if you think about it, back then, do dinosaurs undergo respiration? Answer is yes. So they would have released CO2 into the air. So why is the amount not increasing but is constant? For that, we need to learn something called carbon cycle. Okay, while there are processes that produces CO2, that releases CO2 into the atmosphere, there are also processes that takes in CO2. Alright, I'm quite sure you can think of one offhand, which is photosynthesis. So as mentioned, there are processes that produce CO2. For example, your combustion of fuels. When you burn your hydrocarbons, you produce CO2. Respiration, when we break down food, when we break down glucose, we produce CO2. And then your decay, of matter and decomposition of matter can produce CO2 as well. However, there are also processes that remove CO2, and this would be photosynthesis, and then also something called ocean uptake, so they are being absorbed into the ocean. So way back in time, what happens is that the rate of production of CO2 is actually matched by the rate of removal of CO2. So this cycle that keeps the amount of CO2 in the air constant is known as the carbon cycle. Now, for the purpose of our syllabus, we need to know how to write the equations for these three processes that features in the carbon cycle. In respiration, how is CO2 produced? It's produced when your glucose in food, this glucose reacts with oxygen that we breathe in to produce carbon dioxide as a waste gas. So we breathe out carbon dioxide and also your water. As for combustion of fuels, an example of a fuel that we use is natural gas that we use for cooking. So it will react with oxygen to produce CO2 and water again. So from the equations that we have just written, I hope you can see that these two processes results in the formation of CO2 in the product. So they produce CO2. Now, we also need to learn to write the equation for photosynthesis. The good news is that it's just the opposite of respiration. So if you can recall if you can remember the equation for respiration, you just need to flip it. Now, CO2 plus water, this happens in plants to form your glucose, and it releases oxygen gas. So as you can see again from this equation, your CO2 is being used up, is being consumed in photosynthesis. So before we move on, for the sake of the syllabus, you are required to memorize these three equations. So since there are processes that remove CO2 from the air, why would there be a steady increase after the 1900 and then which continues to increase until today? Is because we are producing more CO2 than can be removed. Okay, so what happens when we produce a lot of CO2? It can lead to an effect called greenhouse effect, and it's not solely caused by CO2, it's also caused by methane, and the other greenhouse gas is also water vapor. Now these three gases, what happens is that they can absorb infrared radiation, which is heat that's emitted by the earth. And when we have a lot of these gases in the atmosphere, what is going to happen is that it will retain the heat, resulting in an increase in the global temperature, which is called your greenhouse effect or global warming. Once again, the build-up of greenhouse gases would lead to an increase in the global temperatures, or a phenomenon known as global warming, which can have other severe effects like unusual weather conditions, mass melting of ice in the poles.